Alright, we are starting the 7th unit for Algebra 1, and today we're going to look at simplifying radicals. So what is a radical? You've seen the radical sign. You've heard of it as a square root term. Sometimes there's a variable, sometimes there's a number inside. This is called the radical. That goofy look shaped thing like this. Whatever is inside of it is known as the radicand. And so you've seen problems where sometimes we'd say, what's the square root of 9? What you're really asking there is what number times itself equals 9, and in that case it's 3. And you can find the square root of any number you want by using a calculator. So it's as simple as, it's one of these blue buttons, so you'd say second square root 9 equals, and tells you it's 3. If you had a number that was not a perfect square like 9, say the square root of 7, you can simply find that out by, again, putting it in your calculator, and that will give you a decimal approximation of what the square root of 7 is. But I'm more interested in, instead of approximating, are there ways to simplify them? And to do that, actually, you're going to need to take what the radicand is, prime factor it, and see if there is a perfect square factor inside your radicand. Here's an example of what I mean by that. When I took the square root of 9, what I was really doing was, in my mind, prime factoring 9. I have a pair of 3's, so the answer is 3. But what if I would have had, say, the square root of 18, and I prime factored it? I'd get 18 is 2 times 9 is 3 times 3, so I'd get 3 squared times 2. Well, the 3 is coming out of the radical, but there's still a 2 left inside. That is the principle behind simplifying radicals. It works with numbers big as you want, but the premise is take the radicand, prime factor it, and look for pairs. So I've got a pair of 2's and another pair of 2's. That means 2 different 2's are coming out, so 2 times 2 is 4, leaving a 2 inside. We can use larger numbers. Take 500. To prime factor 500, it's 5 times 100, which is 10 times 10, which is 2 times 5. So I've got 5 times 5 times 5 times 2 times 2. A pair of 2's and a pair of 5's. 2 times 5 is 10, but the single guy has to stay inside. Sometimes I call this the radical hotel, and the singles have to stay in. Let's try a few more just to make sure we got the concept down. Square root of 75 is 3 times 25, which is 5 times 5. Pair of 5's comes out, 3 stays in. 98. 98 is divisible by 2. It's 2 times 49. 49 is 7 times 7. Pair of 7's comes out, 2 stays behind. And last one, be square root of 27, I should say last one, because we're going to do a couple with variables. 27 is 3 times 9, which is 3 times 3. Pair of 3's come out, single 3 stays back in the hotel. And it works the same way with variables. The square root of x squared, as you might guess, is x. There's 2 x's in there, they come out as 1. Square root of x cubed would be x times x times x. The pair comes out, but one's got to stay behind. So for example, the square root of x to the 7th power, if you've got 7 x's, you've got 1 pair, 2 pair, 3 pair, with 1 single left behind. So you've got x cubed on the outside and 1x still on the inside. That's basically simplifying radicals.